Hello guys, so now we'll discuss 24th January morning shift chemistry paper analysis of JEE main. Okay, okay. Question number one, what actually is talking about? So it's a basic question that you can see here. So vinyl halide, aryl halide, benzyl halide, aryl halide, right? So allyl halide, vinyl halide, benzyl halide, as well as aryl halide. So here, if you see this one, so when halogen is connected to sp2 carbon. Halogen is connected to sp2 carbon. That will be vinyl, vinyl halide. That is means vinyl chloride. If I take here vinyl chloride. If halogen is connected to sp3 carbon, if halogen is connected to sp3 carbon, that is allylic, allylic chloride. And take here allylic chloride. This one. Now, when again, in the case of aromatic condition, if halogen is connected to sp2 carbon, this carbon is sp2, then that will be aryl chloride, or can say what is that? Chlorobenzene. So aryl chloride we can call this one. If in the case of aromatic, if halogen is connected to sp3 carbon, this carbon now will be sp3 carbon, that will be benzyl, benzyl chloride. This one. So what are the options we have? Vinyl. Vinyl halide means that will be A1. So A1 means 1 will not come, 2, 4 will not come. And allyl halide. So B2, A1, B2, A1, B2. So yes. And C benzyl halide. So sp3 carbon connected to chlorine. So this will be benzyl halide. Aryl halide. So D4. So that means option 2 will be the correct answer for this question. The correct order of stability of following diazonium ions. So here, let us take diazonium chloride will be like this. So here, diazonium chloride, if you take here like this, Ndo positive, Cl negative, right? So assume that if it is forming kind of slightly carbocation, if nitrogen leave, what happen? Slightly positive charge will produce on the phenyl carbocation, but it will not form carbocation. Okay. So now, if you see based on the carbocation stabilizes by carbocation is proportional to the stability of carbocation, stability of carbocation proportional to the plus m comma plus I, right? Is inversely proportional to the minus m and minus I. So we have to see where is a more stable. Now this is strong minus m effect. This will be minus m effect. Here no effect is there. Here because of the lone pair it become plus m effect. Plus m effect, that means stronger plus m effect. So it is a more stability. B must be maximum. So this will not come. This will not come. This will not come. A must be minimum, then after B. So stability D is more than C, then B, then A. That is the order of stability of this diazonium ions. So that is option 1 will be the correct option. Now they have given the some conversions. So just look at this one. So if you see here, A is giving with the essential HCl. So A gives rise to SnCl2 plus HCl. Second step is hydrolysis we are doing. Then B is forming. That means we'll see. Then after KMnO4, KMnO4 acidic medium. That means it is a strong oxidizing agent. It can convert alcohol aldehyde into carboxylic acid. C is that means what happened? B must be either alcohol or aldehyde, right? C must be carboxylic acid will come, right? C must be carboxylic acid. Now, if you treat with the C, Cl2 plus red phosphorus, Cl2 plus red phosphorus, and followed by hydrolysis, you will get the C3H5O2 Cl2. So, this particular compound is chiral, has one chiral center. Now, here how many carbons are there? Three carbons are there. So three carbons basis. See, definitely this fourth option as well as second option, they cannot be A. They're asking which of the following can be the A. Your options must be either one or three. Let me try to see the first option whether it is coming or not. Okay, so let us take, so if I take this one, C triple bond N. So what if I take this one? Stephen's reduction only, no? Stephen's reduction. So what it will do first? Imine conversion will be there. First will be imine conversion. H double bond NH. Then if you do hydrolysis, no? So what will happen? So break this pi bond. H positive, OH negative. Again OH negative, H positive. So we'll be getting, so will be C double bond O. 2OH will be not stable and single carbon. Elimination of water plus ammonia will be forming. Plus ammonia will be forming here. Plus water also will come out. So what you got here is B, you got it. Now B, if you treat with the KMnO4, KMnO4 acid medium. Aldehydes converting into carboxylic acid. So nascent oxygen will come. This will trap here. So what happen now? C double bond O, OH. So you got the carboxylic acid, that is C. Carboxylic acid. This is what you got C. Now C, if you treat with the Cl2 plus red phosphorus followed by water. This will be HVZ reaction. HVZ reaction. What HVZ reaction is telling that alpha position remove the hydrogen. Alpha position hydrogen remove and replace the chlorine. So you can keep here C double bond O, OH, remove the hydrogen here, replace the chlorine. So this one you can see here, chiral center will be there. So that means what happened? You have the option is A is the correct option. If I take the C, no, number of carbons are not coming equal to the product. So option A is the correct method for this question. Now, if you see the question number, next one, which of the following compound contain three unpaired electrons? Three unpaired electrons it will be having. Suppose, let us see here vanadium. Vanadium here plus 5 state, right? So that means what happened? Atomic number of vanadium will be 23. 23 means 4s2, 3d3. Plus 5 means all electrons are removed. That means it will be getting organ configuration. N is equal to 0. If you take titanium, here is titanium plus 3. Plus 3 means what happened? Titanium atomic number 23 or 22, right? That means 4s2, 3d2. Here, if you move 3 electron, no, you will get d1. N is equal to 1 is coming. That means number of unpaired electrons is will be 1. Here, cobalt will be plus, how much is coming? Cobalt will be plus 2 is coming. Cobalt plus 2. Atomic number of cobalt is 27. So, Ar 4s2, 3d7. Now remove the 2 electrons from that. So 3d7 is coming. If you see the 3d7, so 1, 2, 3, 4. So 1, 2, 3, 4, 5, 6, 7. So here you are getting the answer. Number of unpaired electron 3 is coming. Here iron is plus 3. Atomic number of iron is 26. So here Ar 4s2, 3d6. From this 3 electrons, if you remove, no, 3d5 will come. That means you will be having the 5 unpaired electrons are available for this case. 1, 2, 3, 4, 5. N is equal to 5. So they're asking only 3 a number of unpaired electrons. That will be option C is the correct answer for this question. Now next question, the correct order of dipole moment. So dipole moment formula what we have. So D into charge Q. This refer the size. This refer the charge. Right? So here this formula if you use here. So dipole moment what happened here? If you take this one, no, this is more electronegative. It will try to pull towards the this direction. Here again oxygen is more electronegative compared to carbon. It will pull toward the this one. Right? So here in this case, what will happen? Let us draw the structure of this one. like this. Okay. So here this will be having the more minus sum effect. You can see dipole moment is maximum in this case, right? So it will pull toward this direction, right? It will pull toward this direction. So resultant vector will go like this. So here it will be coming towards the this direction and this direction. So that means mu is not equal to 0 in this case. And in this case, you have only upward direction. So here also mu is not equal to 0. And here also mu not equal to 0. But mu is maximum where? Mu is maximum. A is more, B is more, C. That is the case you have. Option 1 will be the correct answer. Which of the following compound will give positive tolerance reagent test? So tolerance reagent will give only this one. No? So which one? Aldehydes will give. Aldehydes, it can be aliphatic as well as aromatic. Both it will give you the this one, right? Then it can also give formic acid also will give the tolerance reagent. Then it will also give you the ethanol also will give you the tolerance reagent. Fourth one, hemiacetal also will give. Hemiacetal will also provide the this one. Like this one. Hemiacetal means HOR, OHOR. Like this. Here what happened? From this H, from this OR you can remove. You will get the aldehyde will come. CH double bond O. So this aldehyde will give you the tolerance reagent. Okay. That means what happened? Try to find out the any of this one having here. Which one will not give? Ketones will not give. Ketones no test for tolerance reagent. So this will give the aldehyde test. That means C we have to find out. Okay. C will give. Then B will not give. B is neither hemiacetal nor any other thing. So B will not give. So this methyl ketone will not give. So it is hemiacetal. If you take here, no, this carbon, this is OR, this is OH, and this again R. So A will give and C will give. That is option 2 is the right answer. Now next question is up from the redox reaction. State of chromium will be how much? Here is plus 6, here minus 1 iodine, here 0. Minus 1 to 0. So 1 electron is transferring, that is for 1 iodine. Here how many iodines are there? 2 iodines. So that means what happened? Multiply 2 here. So 2 electrons going. That means X is equal to 2 number of electrons. Same here. Sulfur how much? Minus 2. Here how much? Elemental state 0. Minus 2 to 0. 2 electron. Here 1 sulfur, here 1 sulfur. So that means Y is equal to 2. X plus Y will be how much? 4. That is option C is the answer. C is the answer. Now it is from the P block. P block. So from the group 17 chapter P block. So IF3. IF3 will be having structure is seesaw structure. IF3 will be having seesaw structure. That means sp3 dehybridization. Seesaw, sorry, T shape. Sorry for the mistake. T shape sp3 dehybridization. That means A2 will come. IF5. IF5 will be having the, so here square pyramidal it will be having. Square pyramidal will be having. If you draw the IF5 structure, you can see this is a square pyramidal, one lone pair. That means what happened? sp3 D2 hybridization. Square pyramidal. Square pyramidal. That means what happened? You will be having the B6. IF7 is the most important structure. IF7 you will be having like this. So you will be having, so pentagonal bipyramidal will be having. Pentagonal bipyramidal. This is the highest number of atoms surrounded by the central atom of interhalogen compound case. So if you try to draw the structure of this one like this, here one pyramidal will come, and below also one pyramidal will come like this. So here sp3 d3 hybridization. Why? So hybridization formula what we have? Hybridization formula we have hybridization hybridization formula number of sigma bonds plus free lone pair. This is the formula for hybridization, guys. Okay. So I have 7 pentagonal bipyramidal. So pentagonal bipyramidal. Bipyramidal. Pentagonal bipyramidal. So C must be A. C must be 1. ClO4 minus. This will be tetrahedral structure. So sp3 4 sigma bond tetra. That is so D3 and A2. D3 A2 and B4. Option C is the right answer. Next, stability of alkenes. So stability of alkenes, what we have seen, it is like this. Number of alpha hydrogens. Number of alpha hydrogens. Right? If number of alpha hydrogens are same. If number of alpha H is same, then so trans is more stable. Trans is more stable than cis. So reason will be due to repulsion of bulky groups. Repulsion of bulky groups. So if you see here, alpha H, alpha H, alpha H, alpha H. So in this case, 12 alpha H is available. So here alpha, 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 9 alpha H is there. And here alpha, alpha, 6 alpha H. Here also alpha, alpha, 6 alpha H. It is a form of cis, it is a form of trans. So obviously one is more stable, one is more stable, then after two is more stable, then after trans is more stable than cis. So that means this will not come. C is the right answer. Carbanion stability. So here carbanion stability, stability of carbanion proportional to the minus m minus I by plus m and plus I effect. This is the case we have to see. Now, if you see the stability of a given compounds, so here this is minus I plus m. In this case, this will dominate compared to this one. Here no effect is there. Here minus m minus m minus I. So here this will be dominating, not this one. Here minus I plus m. In this case, plus m will be dominating. Here minus m minus I, strong minus I minus m effect dominating. So more minus I, stronger is the effect. So minus m effect order, power of minus m effect order is, so NO2 is more than Cn minus. Okay, so that means E is more stable than C, then A, then B, then D. Right? So EC, A, B, D, that is option 1 is the right answer. Now we have acid base reaction. So when acid react with the metal, it will form H2 gas. H2 gas will produce. And it is sodium bicarbonate. When you treat with this one, you can make it like a positive, negative, negative, positive. Here also negative, positive, and here positive, right? Now here what happens? First H2CO3 will form. This is not stable. CO2 gas release as well as brisk effervescence will come, guys. Brisk effervescence will come. That is the test for this one. So what will get here? Brisk effervescence. This effervescence, that is the reason that CO2 gas is producing. Molar mass of CO2, how much? Molar mass of CO2, carbon 12 plus oxygen 16 into 12, 32. That means 44. Hydrogen 2. So 2 plus 44 how much? 46 is the answer. A is the answer. Now here you have sparingly soluble in cold water, sparingly soluble in at room temperature, sparingly soluble in hot water. So if you take one compound is PbCl2 is sparingly soluble in cold water, but good soluble, but good soluble in hot water, good soluble in hot water. That is, so that means cold water sparingly soluble is what you have. You will be having the PbCl2. You will be having, so you'll be having the PbCl2 here. Sparingly soluble at room temperature, silver chloride. So obviously AlCl3 will not come, guys. AlCl3 will not come. So that ignore the two options. Then here AgCl will be white precipitate, sparingly soluble. Sparingly soluble. Mercurous chloride, Ag2Cl2. That is option C. You will be having correct answer. Now, atomic radius is always more than ionic radius. That is true only. No. If I take this one, atom A, so A minus and A minus 2. Or else you can keep it like this, no? A minus like this. This is a cation. This is a metal. Means element, atom. Keep it here, atom. And this is anion. So anion got extra electron, no? This is more size. And this is this one. So size will be order what happen. Anion is always more than is neutral atom. So A minus is more than A, then A positive. So they given that atomic radius is always more than ionic radius. So that is wrong only, no. And anion is more radius than atomic. So this is the right answer, but this is given statement is wrong answer. Correct order of metallic character, potassium they given. So they given that potassium is more, magnesium is more, aluminum is more, B. Now if you see this is a group 1 element, this is a group 2 element, and this is a group 13 element. Group 13 element. Now this is what we have. Second period, boron is second period, aluminum is third period. Same second period, magnesium will be having here, and same fourth period will be in the potassium. So this will be third period, fourth period, and this become second period. So now metallic character, metallic character proportional to the where. So top to bottom, metallic character increases top to bottom because of less ionization energy and decreases left to right. Decreases left to right. This one. So potassium is more metallic. Then after magnesium. Then after aluminum is more metal than boron. So potassium, magnesium, aluminum, then boron. So the given statement 2 is correct only, but 1 is wrong. 1 is wrong, 2 is correct. That is option 4 is the right answer. Now thermodynamics directly formulas they given. So whenever free expansion they given, if you take the free expansion guys, so will be like this. If I take like this, insulated thermoflask I have taken, right? There is a point of, you can say this in thermoflask insulated, right? Now create some kind of vacuum at one compartment, another compartment you have taken gas. So here, let us take here, I'm taking the one case will be vacuum. So here this will be vacuum and this will be gas. If gas is there means volume is there, no? Right? This much of V1 volume is there. Now if you try to remove this compartment, so what will happen? The gas becomes expanded, no? The gas become expanded. Now the volume what happen? Volume become V2. So V2 is more than V1. That means change in volume we have in this case. But what happened? We have not applied the any pressure externally. That means if I take del V into P external is equal to W, P external 0 means work done becomes 0 always in free expansion. So work done 0. That means you can keep here directly A3 will come. A3. Reversible isothermal expansion direct formula you have, that is work done is equal to minus N R minus nRT ln V2 by V1 we have, or we can also take minus nRT ln P1 by P2 also same in terms of pressure change, in terms of volume change. That means what happen? You will be having the V4 you have. Irreversible case what happens? Same formula. In case of irreversible, W is equal to minus P external into del V. That is you have 1, C1. Adiabatic process what we have, directly we can keep here W is equal to NCV dt. So D2 will be, that means fourth option, third option will not come. So A3, that is second option is the right answer. Now see the question will be having like this. Solution chapter from the class 12. Okay. So here what we have, non-volatile solute A. So of 0.3 gram. Okay, its molecular weight they given. Again another non-volatile solute of molar mass of mass 0.9 gram, molar mass 180 are dissolved in 100 ml of H2O at 27 degrees Celsius. Take I is equal to 1 because if it is non-volatile solute means neither dissociation nor association. So I value will be 1. Now it is having the density 1 gram per ml. So Kb they given, they're asking elevation in boiling point. So let us see what we have the given data. Given data what they given, a solute of how much they given, mass of A 0.3. What is the molar mass of A? 60. Then what is the number of moles of A? Number of moles of A 0.3 by 60 is getting, given mass by molecular mass. So how much you're getting here? 0.01 I'm getting now. By 2 is coming 0. That means 0.005 moles you are getting. That is a case of number of moles of A. Same thing if I take B solute. If I take a B solute, weight of B, how much they given? 0.9. Molar mass of B, how much they given? 180 they given. Now number of moles of B, how much? 0.9 by 180. If you solve this one, you will also get 0.005 will come, number of moles. Then total number of moles what we have? So 0.005 plus 0.005, you get 0.01 is the total number of moles. So relation what we have, del TB is equal to I into Kb into molality we have. Molality formula, do we know molality formula? Molality is equal to number of moles by mass of solvent. Number of moles by mass of solvent in kilogram you have. So this is the formula that we need to apply in this case. Now, I value 1 they given, Kb value they given 0.52. In molality, how much they given? Number of moles, how much you got? 0.01. By mass of solvent is not given. How to find it? For that reason, they given the density as well as ml they given no. So density is equal to mass of solvent by volume. So density is 1 gram per ml they given, and volume will come here 100 ml. So ml cancel out. 100 gram is the mass of solvent we have. Substitute here. If I take this one 100 into convert into kilogram. So right, what do you have? So 100 cancel out. So zero point 0.1 into 0.5. So how much you're getting? Del TB 0.052. That is option B. You are able to see the option B. That is option B is the right answer. Now question you have this one. A solution contain two groups of group 4 cations X2 plus Y2 plus, each at initial concentration is 0.1. So here X2 positive, Y2 positive, their initial concentration is 0.1. This also 0.1 molar given. H2 gas is passed through the H2 gas we are passing through the solution. So How it is saturating? Is saturating xs comma ys will be saturation. Now, given KSP for xs they given, ys they given. What is the minimum concentration of sulfide in sulfide required to begin precipitation of ys? They're asking only ys. Now try to frame the equation. Y2 positive, H2 minus. KSP what happened? Y2 positive, H2 minus. Okay. So KSP they given for the ys 2 into 10 power of minus 27. Y2 positive they given no concentration 0.1. That is 10 power of minus 1 you can take here. 10 power of minus 1. S minus 2. That means S minus 2 sulfide concentration is 2 into 10 power of minus 26 will be the answer for this question. So option A is the correct answer. Next, what is the hybridization and spin only magnetic moment of a complex? Cobalt. Complex they given cobalt, carbonyl, 6Cl3. So this ligand having the zero charge. If I want to find out the oxidation state, no, this charge will be zero, right? So cobalt plus 0 into 6 minus 3 is equal to 0. How minus 3? 3 chlorines are there, no? So that means cobalt will be having the plus 3. Cobalt atomic number what we have? Atomic number of cobalt will be that we can represent in terms of Z 27. Its configuration what we have? AR 4s2 3d7 you have. Now if I remove the 3 electron, no, you will be having left out. So 4s0 3d6 you have. Carbonyl is the strong ligand, strong field ligand. If it is strong field ligand, pairing will takes place. Force pairing will takes place. 1, 2, 3, 4. So 1, 2, 3, 4, 5 and 6. If it is a force pairing, so what happen now? It will be like this. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Why we are making this one? We required coordination number how much? Coordination number 6. If coordination number 6, we need 6 empty orbitals we required. Empty orbitals we required. In that, two d orbitals here we can get after force pairing two inner d orbitals and remaining one s orbital outside. Again, three p orbital become outside. So this becomes what we have 3d and here 4s one orbital. Here 4p three orbitals are there. 1, 2. Now, if the ligand is coming, what happen now? That will donate electron pair for this one. So here CO1, 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 CO1 and CO1 we have. Now what happened in this case? So pairing will take place now because ligand is giving the electrons. So D2 you got, yes you got, P3 you got, D2 sp3 hybridization. Now you guys let me know here, do we have any unpaired electrons are available here? No. That means n is equal to 0. If n is equal to 0, magnetic moment is equal to, magnetic moment that is mu is equal to n into n plus 2, n into n plus 2, Bohr magneton. N is 0, that means 0. That you have option magnetic moment 0 D2 sp3, that is option 1 is the right answer. Sure. For a chemical reaction A to D, for a chemical reaction A to D, so 1 second guys. Okay, charging over, so we need to connect the charger, right? Okay, so now, so what this question actually is talking about, it is from the chemical kinetics of class 12 physical chemistry. Okay, they given that A to D conversion, A to D conversion they given. So step 1 is positive enthalpy, step 2 negative enthalpy, step 3 negative enthalpy. Select the correct energy plot. Correct energy plot, what would be the correct answer? So if you see the question, so enthalpy is positive. Okay. So in this case, when the what is the enthalpy formula you have? Enthalpy is equal to enthalpy is equal to del H is equal to enthalpy of product energy minus reactant energy. No, when this will be positive, when this enthalpy positive only, then this becomes positive will come. That means what happen? Product value is more than reactant value, right? So product value where maximum is coming. Let us see the step one reaction. So here product value, if I take only up to this point, if I take only up to this point, here product is less energy, reactant will be more. Reactant is more in this case, product is less. Reactant is more means you'll get the del H is negative will come here. You will get here, you will get here del H will be negative will come. First step is coming negative. Now if you see here, the first step, here reactant is less, product is more. Positive is coming. Now next step it has to come negative. That means I have to take from the reactant to product. Here product is less, reactant is more. Negative is coming. Here reactant is more, product will be, sorry, product is more, reactant is less. So third step here you're getting positive. So this option will not come. Now let us see the third option what we have. Here reactant and product. Product is more, reactant is less. So positive will come first step. Now second step. This is the reactant, this is the product. Reactant is less, product is more. Positive is coming. We need negative. Failed. Now let us see in this case. Here reactant less, product is more. Positive is coming for this. Now here reactant is less, reactant is more, product is less. Can see this is the reactant, now this is a product. So reactant is more, product is less. That means negative is coming. Fine. Here again product is less, reactant is more, negative is coming. So you have the option 1 is the correct answer. Now numerical type answer what we have. Two solutes AB, they given 0.3 gram, 0.9 gram respectively. Its molar mass 30 gram and 90 gram they given. Dissolved in 100 ml of water. So calculate the osmotic pressure they are asking. Calculate the osmotic pressure. So number of moles of A is equal to how much? 0.3 by 30 only, no? That is 0.1 only come, no? 0.1, 0.01 will come. How? 10 will go. 3 will cancel out. Number of moles of B how much? 0.9 by 90. So we'll get 0.01 mole will come. So total moles is equal to 0.02 will come of this case. Total moles. So what we are going to do osmotic pressure formula, pi is equal to I C R T. C is what? Concentration. R is what? R is what? Constant. Gas constant. T is what? Temperature. Okay. Now try to find out the concentration. Number of moles by volume should be in liter, guys. Number of moles is 0.2. Volume 100 ml they given, convert into liter. So what will happen now? 100 cancel out. You got the 0.2 concentration. You got it. Okay. Concentration you got 0.2. Now What we need here again? So I value, the mention it is non-volatile, no. That means what happened? Non-electrolyte, no. I is equal to 1. Substitute here. So 1 into 0.2 into R value 0.0821, and temperature how much given? 300 Kelvin. So after solving, how much will get? We'll see this one. How much will get? 0.2 into 300 into 0.0821. So we are getting 4.9 is coming. Okay. 4.9 will be the answer is coming. So that means approximately 5. So correct answer is coming 4.9. You can take approximately 5 is the osmotic pressure. So osmotic pressure formula we need to apply like this. R value in this case always 0.0821 liter atmosphere per mole Kelvin. Now you have the atomic structure. One question is framed here. Minimum energy transition of Balmer series. So guys, Balmer series before Lyman, Paschen, Bracket, Pfund will be there. So Lyman series first line starting from where? So 1 to 2, 1 to 3, 1 to 4, 1 to 5. That means you have to represent like this. So 2 to 1, 3 to 1, 4 to 1, 5 to 1. The Balmer what happened? Start from second. So right. So 3 to 2 and 4 to 2 and 5 to 2 and 6 to 2. Paschen what happened? Lyman Balmer Paschen. So here 4 to 3, 5 to 3, 6 to 3. Here bracket what happened? 5 to 4, 6 to 4, 7 to 4. Here P fund. So here 6 to 5. That means what happened? Ground state for this 1, ground state for this 2, ground state for this 3, ground state for this 1 4, ground state for this 1 5. They're asking that minimum energy means what happened? Maximum wavelength energy is proportional to 1 by energy, this one. 1 by lambda or 1 by energy is equal to this one. So that means what happened? I need to take the minimum energy. Minimum energy will be having the first line. This first line will be having the minimum energy you will be having. So Lyman series, Balmer series. Let us take for the case of first Balmer series, B for Balmer series. Read the question. Minimum energy of transition of Balmer series of hydrogen atom has energy L electron volt. So in this case, energy they given as L electron volt they given. If the value of minimum energy of Lyman series minimum energy will be how much they given? In terms of L, that is equal to Y they given. Y. Then the value of 10Y will be how? Substitute here. In this case, so minimum energy means what happened? First line. First line will be the minimum energy. Energy minimum. So 13.6. Okay. 13.6 R Z square only, no? So R Z square. So Z will be 1 per hydrogen atom. So 1 by how much? So 1 by, so N value how much? N value varies from N1 is equal to 2, N2 is equal to 3. First line of Balmer series. So 1 by 4 minus 1 by 9. What is the formula here I'm applying here is this one. So energy is equal to 13.6 Z square 1 by N1 square minus 1 by N2 square. This formula we have to apply in this case. They given in terms of energy only, no. So what will happen now here? This energy they given L is equal to 13.6. So take LCM. So 5 by 36 you got it. This equation number 1 you can make it. This equation number 1. Now come to the Lyman series. In the case of Lyman series, again minimum means what we have, N1 is equal to 1, N2 is equal to 2. So energy is equal to, so 13.6 Z square, again 1 by 1 minus 1 by 4 you have. So 13.6, so 3 by 4 you are getting. Now they given this value, how much they given is Y energy they given. Energy is equal to Y. Now they said that so this has to be in terms of L. That means what happened? Y in terms of L. Equate the equation 1 and equation 2, you will get the answer. Equation 2. You will get the Y value. That Y value you have to substitute in the 10Y. So 13.6, 5 by 36 is equal to 13.6, 3 by 4 is equal to Y. That is why you will get it here. So that's where you will get the Y for the current answer. So 13.6, 13.6 cancel out. So here 4 nines are 36 cancel out. So what we can do, bring this one here. So 5 by 9 is equal to 3 is equal to Y. So what we can keep here? So Y is equal to 27 by 5 will come. 27 by 5 Y value is coming. Now that Y value is substitute here 10 into Y. So what happened now? 10 into 27 by 5. That means what happened? 2 table. So 54 is the answer is coming. The answer for this question is 54. Now we have purification of organic compound. That question little bit they have changed here. So here it is actually it has to be found from the Dumas method. Dumas method. So we need to use the N. Percentage of N is equal to what we use here. So 1.4 into normality into volume by weight of organic compound will use. But in this question, what they given? They have not given the normality. Where we need to not apply this one. First, what we'll do now? We'll try to find out the this method. Percentage of percentage of nitrogen is equal to weight of nitrogen by weight of organic compound into 100. If you do, you will get the percentage formula in this case. Okay. Now, before that, we'll try to find the weight of nitrogen. Further, we have to use PV is equal to nRT. Okay. Pressure of N2, we have to find out pressure of N2 is equal to P minus P1 by what you have P minus P1 by pressure at atmosphere condition. We have to take it right. Pressure at atmosphere condition. So P minus P1, how much we have? So we have P is what? P is the this pressure 750, right? P1 will be the aqueous tension. So 715 minus 15 by 760 you have. So right 700 by 760 you have the pressure of N2. So now substitute here what we want, moles of N2. So pressure into volume by RT. So 700 by 760 into volume they given 34. So 34 they given ml. We need to convert into liters. Why? R value is in liter only, no? Take the R value in terms 10 power of minus 3. Now, what is our value? 0.0821 into temperature. How much? Temperature they have given 300 Kelvin. So after solving, how much we will get the answer here? 0.0821 into 300 into 760. So you got this one. 700 into 0. So 034. So divided by this one. So we'll be getting like this. 23.8 by 18718.8. So we'll be getting number of moles of N2, number of moles of N2. So 23.8 by, so number of moles you are getting, number of moles of N2 0.00127 you got it, moles. Now find the mass of N2. Now find the weight of N2. Moles of N2 0.0127 by molecular mass of N2. So how much will get here? By 28, we'll be getting 4.5 is coming. So this one can make up one the. So number of moles of N2 is equal to weight of N2 by molar mass of N2, right? Now multiply both of them, 0.00127 into 28, 12728 into this one. So 0.3 is coming. Weight of N2 is equal to 0.0355 is coming. Now substitute this weight into this case, this one into this. So what we are getting here, percentage of N is equal to 0.0355 by given organic weight is 0.5 into 100. So by 0.5. So we're getting percentage of N will be so 7.1 percentage is coming. That is the answer for this case. Then next what we have, another question from the chemical kinetics. We have like this. This question already same model repeated guys in the 21st morning shift question. It is repeated as it is. That data alone has been changed. So here Arrhenius equation what happened? A e power of minus A by R into 1 by T. So here catalyzed and uncatalyzed ratio. Let us take the K2 catalyzed, K1 uncatalyzed. So ln we can take here EA by. So so which is more energy? The given del E value how much? Del E A by R into 1 by T. So this value will be varies. When catalyzed reaction, activation energy will be less. When not catalyzed, activation energy is more. Right? So here 10 convert into joules, 10 power of 3 by R value 8 into temperature will be how much? 300 Kelvin. Now we are getting like this. So let us see here 300 into 8 divided by means 10,000 by 300 into 8. You got 4.6, you got it. 4.166, you got it. So what we got here is long term, we got it. Long, but they're asking log term, no? So ln to log. Ln x is equal to 2.303 log x. Now what do you do now? So 2.303 log of K2 by K1. If I take into this one 4.16. So log K2 by K1 is equal to 4.166 by 2.303. So we get 2.303. You're getting 1.8 approximately. You're getting. That means you can take up nearest integer is 2. You're getting. So answer will be 2 for this question. Okay, so thank you guys for this. So again, we'll discuss the next paper of JEE main. Okay, so thank you.